Hello guys, welcome to Base to Learn. In this session, let me explain you the concept of virtual function with a simple example. Virtual function is a member function in base class that can be redefined in the derived class. So this member function in base class will be with the keyword virtual. So virtual keyword informs the compiler that this function has to be binded dynamically during runtime. So normally the function is binded during compile time. So when you are giving the keyword virtual, it will not be binded. It is binded during the runtime. So let me show you an example for this virtual function. Here we had created a shape as a base class and rectangle as a derived class. Single inheritance here. Shape base class and rectangle derived class. Shape base class has some functions: get data, calculate area, and calculate perimeter. So this functions has been redefined in the derived class. So here in C++, the base class pointer can be also used to point the derived class object. Okay, we can call the derived class functions using a base class pointer. Let me show you with the code. Here, this is the pointer for base class, and this pointer can be used to point the derived class object. See here, rectangle is a derived class, so this shape pointer, base class pointer, points to the derived class object. So by using this, we can call the derived class function. So when you are calling get data by using the base class pointer, what happens is it calls the base class function, not the derived class function, because it is binded during compile time. Normally the functions will be binded during compile time. So when you are seeing the get data function, it calls for the base class function and it works the base class function. All this calculate area and calculate perimeter, all the base class functions will be called out. So to avoid this, we need to give a keyword virtual in the base class. So it calls for a correct function. When you are calling this function using a base class pointer, by seeing this keyword virtual, the compiler will not bind the function during compile time. It waits until the line of execution. So when this line gets executed, shape.getData, it searches for a base class because the object is mapped to the base class. So by seeing this virtual keyword, it works for a get data function in the derived class. Next one, calculate area. It searches for a base class and it will see the keyword virtual. By seeing this keyword virtual, it calls for the function calculate area. The same for calculate perimeter. Now you know the purpose of virtual keyword. The virtual keyword informs the compiler to bind the correct function during runtime. So now you will be clear about the virtual function, why we are using virtual function in C++. So let me show you a clear example for this virtual function. Here we are going to create a base class shape with a two virtual functions, calculate area and calculate perimeter. So here I had created a shape as a base class and these are all virtual function. Get data, calculate area and calculate perimeter are virtual functions. Next we are going to create three classes, that is square, rectangle and triangle. So we are going to create three derived classes, okay, and uses the functions of base class. So base class and derived class, we are going to create a rectangle and and with the same functionalities: get data, calculate area, calculate perimeter. Next is square. Square with the same functionalities. Triangle with the same functionalities. We are going to add one more data to this as side. So let us see the code for this structure. Shape. Shape is a base class. In the base class, we are going to um, declare the object type. Object type is here it is double. Okay. So here we are going to declare the object type. It is double length and breadth, and the visibility mode here is protected. We all know the visibility mode. There are three types of visibility modes in C++: private, public, and protected. Private, it is visibility, the visibility is only within the class. Protected, it can be visible to the derived class. So we are using protected in this base class. Next, the functions. The functions are all with the keyword virtual. So this means this can be binded during runtime. Next, this is equal to 0. The function, virtual function, is equal to 0. What it means is it is a pure virtual function. So it informs the compiler that this function doesn't have any body. It has only declaration. The base class has only declaration. All the definitions is in the derived class. So this is the information for a base class. So the word we are using here is pure virtual function. So next, let's write a code for your derived classes. So this is the code for derived class. Public, we are going to write a code for get data, calculate area, and calculate perimeter. So it returns a double value. Okay, the same thing for rectangle. Get data, calculate area, and calculate perimeter. The same for triangle. Get data, calculate area, and calculate perimeter. The only this formula gets differ to calculate the triangle area and perimeter. So the next one is now we had written the code for all the base class and derived class. Now we can write a code for main function to access this. So here in the main function, first line is we had created a pointer, a single pointer for base class. Shape is a base class. We had created a pointer for base class. By using this base class pointer, we are going to access the derived class. Rectangle is a derived class, and the shape points to the derived class object. By using this base class pointer, we are calling the function get data. Now derived class function will be called off. The same with calculate area and calculate perimeter. Rectangle functions, rectangle class functions will be called by using a base class pointer. So the same will be for triangle and square. Here we had created a object for triangle, and this base class pointer, now it is pointing to a derived class triangle. Now when the base class pointer calls for a get data, it calls for the triangle class functions. So this is the concept of virtual function. It binds only during runtime. Now it matches perfectly. So now here all the functions in the triangle class will be called off. The same for square also. The square functions will be called off. So this is how the virtual functions gets worked. Let me show you how this code gets executed. So here is a code for virtual function. Here this is a base class with the pure virtual function, virtual get data equal to 0, double area equal to 0, perimeter equal to 0. So this is a base class. Then here is a derived class. Derived class has three functionalities: get data, calculate area, and calculate perimeter. So the same functionalities for square, only the formula gets differ for calculating area and perimeter for square and rectangle. And then for triangle we are going to get another one data side. So we had declared another data double as double side. Next we had declared all the classes. Now we had written the code for a main function. We are going to create a base pointer that points to a derived class objects, rectangle, triangle, and square. By using this we are going to call the functions. So let's execute this code. So it asks for the length and breadth of a rectangle. I am giving 2 as length and 5 as breadth. Okay, so it displays area and perimeter of a rectangle. Now it asks for triangle. Height is 4, base is something I'll give as 6, and the side I'll give as 4. Okay, so it calculates for a triangle. Next for square only side, so I'm giving 5, so it displays the square result. I hope it will be clear in virtual functions. Thank you for watching.